Aloha from Math Camp. I'm Dane, and today's mini lesson is about graphing trigonometric functions with Cartesian coordinates and polar coordinates using Geogebra, all in less than 5 minutes. I'm thinking you may get more out of this if you downloaded a free copy of Geogebra first. First of all, you need to open Geogebra Classic. Go to Graphing, and then type in y equals a times sine. Don't forget times, because if you don't do that, it's going to assume it's arc sine. Trust me, I've tried it. Times b x minus c, and then use the arrow keys to get out of that, and then plus d. If you push Entrée, you get something that looks like this. Best thing to do, I think, at this point is to move c back to 0 and d back to 0. And now you can play around with the amplitude and the period. But we're after bigger game. Type in r equals a times sine theta. Well, I'm sorry, you have to do b first, times theta minus c. Now to get theta, you go to your keyboard here and notice above there, there's the Greek letters. You pick theta minus c, exit that, and then go plus d, and you have that. Now, you can play around with the Cartesian form of the trigonometric function or the polar form of the trigonometric function, but the nice thing is we got them both together. So if you play around with a, let's say I slide this back and forth. Why is that true? You've got a circle that gets bigger and smaller and ends up sometimes underneath the x-axis and sometimes over the x-axis. Isn't that cool? And then if you change b, which is, of course, the period thing. Oh, I'm sorry. We won't do that. I'm going to save that till last. If you change c, the Cartesian graph goes to the left and to the right, but the polar graph just rotates around the origin. Why is that? Well, that's something you can play with. What about d? That just moves the Cartesian graph up and down, but look what it does to the polar graph. Let's see, when I touch the axis, I get that little cusp. And when I go below the axis, there's a little curl. Wonder why that is. Well, that's something you can play around with. And, okay, one more time. If I have trouble with this, all you have to do is type in d equals 0. So now we try b. This is the one that's really fun. If you start sliding that, look what you get. Okay, there's a cardioid, but okay, it's kind of splitting open. What's going on here? Oh, on here I get I get a propeller kind of little rose thing. Well, problem is the input for theta only goes from 0 to 2 pi. What if I picked something, let's just say 12 pi instead of 2 pi? Let's see what happens. Well, then when I slide this, I get more, don't I? Look at that. That's so cool. Why is that? What's going on here? Guess what? You can play with it, and you can find out.